So, hello everyone. First up, let me start by introducing myself. My name is Pranav Prashant and I'm a final year undergraduate student at NIT Calicut. I'm majoring in computer science. Today's video will be discussing on the product that I have built as a summer extern at AlgoUniversity, and this is a presentation corresponding to that. So this is an online coding judge, which is basically a clone of Lead Code, Geeks for Geeks, or any other online IDs that you see around. Now, this I've used a microservice architecture based approach in which I have different servers for the database and the compiler, like the one that does the entire operation. Let me explain you in brief about what these things exactly do. Now, the server is nothing but it does the CRUD operations of the contest, of the leaderboard. Contest and leaderboard are related to each other with a foreign key, and then problem controller and test case are related to each other by a foreign key, and submission controller is not associated with any other thing, but it is basically to store the information of the submissions made, number of submissions, the time and date of the submission, etc. And this user controller is to basically do the authentication kind of operations. Now this is the .env file, and then this is the server.js, where everything is, all the APIs are actually defined, and I like it this way. This looks very much structured, that everything related to submission is here, everything related to contest is here, and then test case and everything is here. Now server is done. Now let's go to the compiler. Compiler is what it does is it takes in the input code, input language that the user is using to the backend, and then runs a shell script file. Let me show you. This is the execute part of the code. How it executes is it compiles the code with respect to the language it got. For example, it takes in input the file path and the input path, and it executes this by this shell script command, which is g++ std. This is to basically include the latest libraries of the C++, and that's the basic way how we compile a C++ code, that is g++ -o and then the path. After that, so based on the language that the user is using, we have different kind of compilers. That is to execute the CPP code, this is to execute the Python code, and so on. We have 4 particular languages that is included in the online judge. More on that while I explain the front end part. Now after this, I have included a Gemini API based LLM that is to do a robust code analysis of the code. Basically tells you the time complexity and the approach that you have taken, and it is nothing but a functionality of generative AI that I have used. Now this is index.js, which calls in all the files accordingly. What this does is it takes in the language from the user, it takes in the code, and this input and problem ID, this is corresponding to the verification purpose, like it to get the verdict. If for example user is using a custom input, I am taking the custom input and then sending it to the request body, and if the user is not using the custom input, I am having a problem ID, and so we'll fetch the test cases corresponding. I told you in the other part of the server wherein the CRUD operations are being handled. So what do? We take the test cases corresponding to this problem, and then give the verdict to the user if his or her code is correct or not. Now this is the verdict, where what it does is it tells you the verdict. Basically what it does is it takes the response, and response is nothing but the test cases corresponding to this particular problem ID, which we take using the use params. This is a part of the parameter, and it does nothing but comparing. If it gets a set of test cases, now it compares, and now the test cases are very much robust. I have taken into possibilities lesser number of test cases, but it tries to cover all the extreme level of test cases that it can go, like large numbers, negative numbers, and no imports and stuff like that. So it just runs a for loop to for all the test cases that is there in the backend, matches it with the user output, and then if there is any test cases that is being failed, will return that particular test cases in the front end and tell the user that it is corresponding to this test case that your code is failing. If you can make any changes and re-upload it, you can. Now I have done everything and then compiled it with the Docker file. I have also integrated CI/CD pipelines using the GitHub Actions, and this is the Docker file that I've created. It does nothing but it fetches the node package, initializes the working directory, and then takes in all the libraries that are required. Shell commands, for executing shell commands we need some libraries, and it is taking all these. Basically these are C++, JavaScript, Java and Python packages, and these are the run commands. And then we copy all the things that we have, all these node modules kind of things and these packages into the working directory application. And then we have exposed this 8080 port to which we are running the compiler, and then this is the run command of the compiler, that is node-mon or node index.js. Now having done that, these are the 3 folders where inputs are being stored and the code itself is being stored and the output. And after that there's nothing much left here. Yeah, there's nothing. Now after that, for the client part, we'll not explain the code but go through the application itself, and it will be easier that way. Now let's start the server first, because the compiler hits onto the server now before initializing itself. It checks if the server is up and running, because we are fetching the test case corresponding to a problem ID. So node-mon server.js, fine, it's running on port 9000. And let me just change one small thing. Let me go to this and change the URL to the local host. Yep, this way it's fast, because cloud servers are it's slow kind of, because we use shared and free kind tier, so it's a little slow. After this, what are we gonna do? We are gonna, fine, for the compiler part also let me change one small thing. For the verdict thing, let me call this localhost instead of this. Fine, all set. Let's begin running this now. Node-mon index.js, and it's up and running at port 8080, and now the front end itself npm run start. This will run on the port 3000. Fine. So this is the application. It will basically has this problem page where we have a set of problems. Now if you go to any problem, for example let's say 2sum, and you solve this problem, for example, you have to just check if the software works, or you are in doubt in how to solve the problem. You just go to the editorial page. This has well curated solution for all the 4 languages that I've mentioned, and you can copy any of those. For example, let's copy C++, copy solution, you'll get the fine. You can now paste it here. You can now run and check if everything is fine. If everything is fine, if the backend is running well, it should give you an output. But yeah, fine. So we are getting an output of 0 1. Now for getting to know the verdict and time complexity analysis, you will have to submit it only then will you be able to see those things. I have submitted it after, let's say, 5 6 8 seconds it takes, because this is a generative AI based kind of thing. It takes time to generate this. Okay, fine. So now verdict is that all the test cases are passed. Now time complexity analysis, this is basically the code analysis. Tells you the program runs in order of n, and of course 2sum runs in order of n only, and the approach I have mentioned here is order of n only, and it basically analyzes the code right away. And in case you have to let's say check for the custom test case, you have that facility also. You have to first input the test case, like the size of the array 4. Now we are going with this test case. Okay, 2 7 11 15, 2 7 11 and 15, and the target is 9. What is the expected output? The expected output is 0 and 1. So 0 and 1. Let's verify it if it's right. Fine, so we get the response. Congratulations, the output is as you expected. Now let's say we change this to 0 and 3, which is not the actual output. So you verify and you get the output isn't as you expected. So that way you can verify the custom test case kind of thing. Now after that, We have other features of fine. So we have this problem of the day kind of thing. Now random problem, let's go here first. So this will generate you a random question which you can solve after you have completed the entire DSA preparation. You can, regardless of what topic you're solving or what kind of patterns you are going across, you can get a random pattern, random problem. And a little bit improved version of random problem is the problem of the day, which gives you the problem corresponding to that day. For example, today is 14th July and we are getting a problem corresponding to 14th July, and this is not at all hard coded. It takes in the date using the JavaScript library, JavaScript, and then gives you a random problem, and regardless of how many times you refresh, this will be the random problem of the day, because it stores the information in the cookie once you load it for the first time, and it stores it then and there. So after that, what you do, you have completed this random problem thing, problems page, and the problem of the day page. You have this compiler thing where you can, let's say user just wants to come and check if his code is working or not, and you just have to go through your code once. So you just, let's reset this once and run this, and you get to see the output here. And you can do this for any language. Python, for example, you run, you'll see Python ka output aaya, and if you go to JavaScript and if you run it, you'll see Java. So I could have included other languages as well, but I wanted to make my Docker file crisp and clear, like small, because we are using shared servers, so it's better to just go with the 4 mainstream language that is industry relevant. And now this is the sign-in page, which basically does the authentication kind of purpose. I have not made it mandatory for anyone to sign in to use the compiler. The reason being, it gives you a little bit of inertia in using the platform. I want users at this point, so that's why. And having done that, I have not implemented the contests page as of yet, but once I get good number of users, I think I will include this as well in the near future. And that's it. That was the front end part, and that was the features that I have. The mode of the program, like the coding compiler, is this generative AI based tool assistant that we have given. And the reason being, that is something that is not even available on LeetCode these days. We just have one free trial, like you could just get to know the time complexity of any problem once. So in that case, you can come here and paste your code in the compiler. I would include that in the compiler also, and you'll get to know the code here. And of course, that is also on the free tier, but we have good enough 15 requests per minute limit, so that is how it is. And this was my presentation, and thanks AlgoUniversity for giving me this opportunity, and it was really fun making this project. And that was it for today, and thank you for your patient hearing, and bye.